So welcome to session 1 of Inspiring Future STEM Stars. This is my Gold Award project. My name is Hannah Zawaideh. I have been a Girl Scout for going on 11 years now, and I look forward to sharing my passion with STEM with all of you. So I am pleased to welcome our guest speaker, Mikala Shremshock, an FLIR science engineer. Please all welcome Mikala.
Hello, everybody.
Hi.
Hi.
If you would like to share your screen, thank you.
You'll need to stop sharing before I can share.
Oh, I'm sorry. Okay.
All right, got it. All right, can I get a thumbs up if everybody can see my screen? Should have some baby chicks up in the corner. Okay, perfect. All right, hi everybody. Thank you, Hannah, for arranging this. I'm glad to see all of you here. I know these are strange times. I see some people cooking and baking and eating. That's one of my favorite things to do. So Hannah asked me to talk a little bit about how I got here and what my job is and what I do, and I'll share some details about the cameras that I work with. Here's a picture of just some baby chicks, and you can see they look a little different than they normally do, so maybe we'll find out why during the next couple minutes. My name is Mikala, and I'm a science sales engineer for a company called FLIR Thermal Imaging. What this means is that I run around and do application support and sales support, and they throw engineer at the end of everybody's title now. So I don't have an engineering degree, but that's still what my job title is. Like I said, we'll talk a little bit about how did I get here, what my path through life has been. Like you, when I was a little girl, I didn't even know my job title existed. But there's been some curveballs along the way, and I'm sure your friends and family will have similar stories about how they ended up where they are. So even if you only think you want to be a lawyer, a doctor, an astronaut, there's lots of other jobs, especially in STEM and science, that you can think about. And then we'll get to the science part. Then we'll get to the cool part. We'll talk about the cameras that I work with called infrared cameras and what you can do with them. It's not always giraffes and butterflies, but there's some of that in there. So I'm gonna start off with high school. I know some of you are a little younger than that. When I was your age, I was involved in all sorts of things, mostly playing in the dirt, I would say. I grew up on a really small farm, so we had a garden, we had some animals in my backyard, and my parents were very good at, making sure I had books to read. That was probably one of the biggest things that I was interested in when I was a kid, was just reading. We always had an encyclopedia. You guys probably don't know what that is anymore, but it's basically the paper version of Google. And if you wanted to know what something was, you had to pull out this giant book and flip through the pages. But once I went to high school, I had some really great teachers, and one of my favorite subjects was math. And I just love the numbers and even the geometry and understanding how all of this related to the world around us. I also really enjoyed biology. I liked playing in the woods and looking at trees and identifying plants and bugs and playing with animals. And then, like I said, I really liked literature too. I had some great English teachers and I enjoyed writing. And that was what I really thought I was going to be when I grew up. I wanted to be a writer or write for a magazine or something. I took Spanish as my foreign language. It's one of the more common languages that are taught in schools, and I knew it would be useful because a lot of the world speaks it. I'm not so good with Spanish anymore, but when I travel to Spanish-speaking countries, I at least get a chance to practice it. And then I played a lot of sports in high school too. One of my favorites was volleyball, and I think this is one of the most important things that I've had in my life, is I've always had some sort of athletic outlet that I could get away from the books and get away from reading and do something else, either with other people or just on my own, just as a way to think about different things and turn your brain off and have some physical activity. So then I went to college and I thought I was going to be a vet. I really liked animals, but I really enjoyed my chemistry classes. The very first day of chemistry class, my professor said, if you want to, you can come help out in the lab. And I thought I was going to be, washing beakers and copying down people's lab notes, and it was going to be a boring job, but at least it would be something. But it was wonderful. I had my own research project, and there's a picture of me there on the left working with an instrument called an atomic force microscope. So it doesn't look like the microscopes you're used to seeing, because this can actually see much smaller things. It can see down to nanoscale. So that's like 100th of the size of the width of one of your hairs, really teeny tiny things. And I got to work with DNA and these things called quantum dots that glow in the dark. And then I also got to incorporate math. There's always math in this world, right? Even if you try to avoid it, you always have to know the shape of something or the size of something, or calculate the price, or how much gas you need to fill up your car, how much air you need to put in your bike tires. And then biology too. Like I said, I worked with DNA, so understanding what these molecules were and what they were useful for and their properties was really important. Again, I tried to stay active in other areas of the university. I was in student government. This means I was on a student board that helped tell the university what we needed as students and how things were going. So I represented the College of Science. And then I was also really big into martial arts. Again, this is just a way for me to have something outside of the classroom that I could engage my body and sort of give my mind a break. And this is often when you finally solve that really hard homework problem, is when you stop focusing on it and stop thinking about it for a minute. I wasn't ready to get a real job yet, so I went to graduate school and I specialized in inorganic chemistry. So you guys know the periodic table. The rest of chemistry focuses on a single element called carbon, but inorganic chemistry gets the whole rest of the periodic table to play with. And that's what I really enjoyed. You can tell colors are very important to me. I was always drawn to bright, multicolored things. So on the right-hand side, that's a picture of a cell. So like a cell that's in your human body, but it's been dyed with these quantum dots that glow in the dark when you shine a light on them. And I just thought the colors were pretty and making them was pretty, and also very educational. This was for some cancer research to help find cures for cancer. So that was very good. And there's a picture of me there with my syringe pump. There are days in the lab that are not very glorious, and having to very slowly sit there and squeeze a syringe by hand to deliver droplets of fluid to a mixture is no fun. So this is just an automated way to do that. It's a little motorized contraption that will push fluid into a reaction. One of the best parts about the research I did in grad school was it was so interdisciplinary. So that means that I just got to work with a bunch of different people. I had a really big playground. I worked with people in the pharmacy department, and people in the engineering department, and people in the physics department. And it was nice because I got to interact with so many people and have so many friends in these different areas, but also seeing their approach to how they solve problems. I might think of something one way, but they would have a completely different look on it, or what they saw as a problem wasn't even a problem. It was a really good thing to incorporate into my research. And then you can see in graduate school is where stuff really got hard, and my list of interests slimmed down a lot. The only thing I was really able to do besides my research and studying for classes was running, but that is something that I've kept with to this day. I still run marathons in my free time, and really enjoy the training, and it's given me the opportunity to travel a lot as well. So then my first job was with a company called Bruker Nano, and I was something called a field service engineer. What this means is that I traveled, and then I traveled some more, and then I traveled some more. Throughout the US and also around the world, I supported customers in North America and South America, and I had a lot of trips to Brazil and Argentina. And what I did is that when people would have these microscopes, they needed someone to show them how to use them. They needed someone to set them up for them, and that was what I did. When they had a tough problem that they couldn't solve, I would show up on site and help them fix it. I would help them, come up with good ideas for applications. But then whenever the work got really hard and really boring, I could skitter away and go off and do something else, and they could focus back on their research. So it's a little bit of something different every day, but you're not stuck in the same place all the time. So for me, that was really perfect. Then the travel got a little bit too much, so I worked for a place called the National Institute Standards and Technology. This is located in Maryland, and they are the folks that certify that your gallon of milk is actually a gallon of milk, that your ruler is really measuring 1 foot, that your shoes are the right size, that your gallon of gasoline is really a gallon. But what I did was manage 16 of their labs for the guests that would come in, the guest researchers. And so again, it was a lot of troubleshooting whenever a piece of equipment would break. You know, stuff always breaks. And it was up to me to figure out what was wrong with it and how to fix it. And then when people wanted to do a new experiment, get them set up with all the right supplies and help them figure out how they were going to accomplish their goals. So that was a really great opportunity. But I was going into an office every day, you know, drinking the same bad coffee every day, and interacting with people. So now I'm with a company called FLIR, and this is kind of a mixture of the 2 previous jobs I had. So FLIR sells infrared cameras, and I help people solve their problems with these. Before this year, I would travel to meet them and interact with them, train them how to use them, and help them solve their problems. Now we do a lot of this, right? We do a lot of video conferences and interacting virtually to help show people what they do. So this is a picture of my desk on the left. This is what it normally looks like. I've got cameras and computers and gadgets running all the time. You know, trying to do experiments to figure out what will help a customer and what will work, and, you know, just for my own sake, what else I can do and how I can tinker with things. Sometimes I use them for myself. I'm trying to find something in my house that's broken, and this can be really helpful. So now I'm working from home, and I do this support whenever I can. And this picture in the middle is a picture of a PCB. So this is what's inside your phone or your computer and how it works. And no matter what anybody tells you their job is, I guarantee you they spend a lot of time in front of a computer doing reports. These are even prettier graphs than I get to work with. A lot of it is just a boring old Excel spreadsheet. And everybody's job, no matter what you do, will involve a lot of reporting. And then I also do sales, again, not during a pandemic, but during normal times. I go to trade shows and conferences and talk to people about what infrared cameras are and all of their capabilities, and how it might help solve their problems. So it's a lot of listening to people and a lot of understanding what will happen if they can't solve their problem. So like I said, the company I work for is called FLIR. That's actually an acronym. It stands for Forward Looking Infrared. So FLIR, that's how they get the name for it. So forward looking, you can figure out what that means. That just means it's looking towards the front of the camera. It's not looking at light infrared coming through a substance. It's looking forward at it. And then infrared is what we're going to talk about now for a couple minutes. In order to understand infrared, we need to know that it's a type of light. And then we need to know what colors are and what wavelengths are and how all of these terms connect to each other. So when I think of colors, I always think of Roy G. Biv, right? This is whenever you go outside after a rainstorm and you see a really pretty rainbow, and you can see all the different colors of the rainbow. You have red, orange, yellow, green, blue, indigo, and violet. They're always in this order. They're never reversed. Every rainbow you see will look exactly the same. And it's actually made from breaking up white light. So, you know, the light that comes out of your light bulbs in your house or your flashlight on your phone, that's all just regular white light. But inside of that white light are actually all of these different colors. And whenever they combine, that's what we see as white light. These colors, the red, the orange, the violet, are actually different wavelengths. So you know what waves are, right? They come from the ocean. And you can think of a wave cresting and falling. So the tops of the waves are called crests. And the distance from the top of one wave to the top of another, that's a wave length, right? The length of one wave. So in the ocean, they're not very consistent, right? You might get pummeled by waves, you might not, and then you'll be a little lull for a while, and then they'll come back. But with light, they're very consistent. It's always the same distance from one wave to the next. So you can see in the picture I have on the bottom right, red light has really long wavelengths, right? That's the longest distance between the top of one red peak to the top of another red peak. And then on the other end, on the bottom, you have violet, which has very short distances between peak to peak. So that's what we mean when we say wavelengths, and that's what determines different colors. But there's other types of wavelengths of light outside of those colors, right? So we have the red to the violet, but then what happens beyond red and violet? You might think whenever you go outside, you might put on sunscreen or some sort of UV blocking clothes, right? So that's ultraviolet. That's what UV stands for. And that's what the sun emits and can burn our skin or make us, get blisters if we stay out too long. So that's ultra and violet. So that makes sense that that's on the violet end of the spectrum. And then beyond the other end of the spectrum on the right-hand side, on longer wavelengths, we have infrared. So that's beyond red light. So the visible spectrum is just this teeny tiny little section of light. The violet to red that we see, that everything in our world we think of is made up, that's just one little bit of all the light and all the radiation that's coming off of everything. A much bigger part is the infrared region. And the infrared region, just like colors, is divvied up into different sections. So instead of having violet, indigo, blue, green, etc., we have near IR, short IR, mid IR, and then long IR. So we call these SWIR for short wavelength infrared, MWIR, mid wave infrared, and then long wave infrared. Now the cameras that look at these different spectrums can take all different shapes and sizes. You might have, so on the left, I have just a regular iPhone, right? You have a phone that you can take pictures with, or one of these fancy DSLR cameras that you can take pictures with, but that only sees the visible light. That only sees the violet to red. If you want to look at these infrared, then you need a special camera called an infrared camera. So that we do make some that plug into the bottom of your iPhone. It's called a FLIR 1, and these are very handy just to take around in your pocket. You can take a look at things and see what they're doing. We have bigger ones like handheld units, and these you might start seeing more often. And then we have the really big science cameras that are used to look at rocket launches and fast things that are going on in the world. So what exactly does an infrared camera see? So an infrared camera is a passive detector. It's not spitting out anything. It's not shooting infrared rays at anybody. It's just observing, just like a regular camera. So it's not gonna hurt you in any way. It's not gonna heat anything up. It's not gonna do anything. It's completely passive. What it does is it detects heat or infrared radiation coming from all the surfaces around us. And everything around us is either reflecting infrared or it's generating heat from itself, right? So you're hot right now compared to the surroundings. So you're generating infrared heat. Like I said, you cannot see infrared with your eyes. This is beyond the red in the visible spectrum. So you don't detect this infrared at all. So it's kind of like having a superpower. So if you have an infrared camera, you actually are kind of a superhero. So what can we do with this? Let's take a look. The one thing I do want to mention is I'm going to show lots of pretty colors and lots of pretty pictures. It doesn't mean anything. Whenever an IR camera is detecting infrared, it's just detecting intensity. So we call this intensity count. So like 10 is more than 1, so 1,000 is more than 10. And these are mapped to different colors. So I have 3 different pictures here of ants, right? We have the pretty purple and blue one, the green one, and then the grayscale one. This is all the same exact image. It's the same data. We've just put falsely colored or pseudo-colored information on top of that. This helps us pick up the differences in temperature variation. So like on the body of the ants, you can't see the differences very well in the green or grayscale images, but you can in the rainbow colored one. So anytime you're looking at one of these infrared images, it's important to know what the scale bar is. So the scale bar is the thing shown on the right-hand side of both of these pictures. On the top one with the cat, that's my kitty, by the way. Her name's Lucky. It goes from 33.6, that's what the white color is, the yellowish white. And then down at the bottom, the dark purple is 21.7. Now, what units are those, right? We don't know. I know because I took this picture. So it's actually in Celsius or centigrade. That's not very common here in the US, but it is used all the time in science. That's how almost all temperatures are taken in science. And then the picture at the bottom my friend took in San Francisco of the Golden Gate Bridge, this one has a much wider temperature range. The whitish yellow color is 28.5, so you know it's a warmish day. But then the very bottom is minus 36.7, so that's below freezing. 0 on the Celsius scale is freezing. So how could it possibly be that cold? Well, if you look at where the blue is, it's actually the sky, right? And so there's no infrared or very little infrared being reflected from the sky. You can see there aren't any clouds. I think this was even at nighttime when he took this picture. So it looks very cold. So whenever you're looking at one of these infrared images or any image that's pseudo-colored, you need to know what the scale bar is. This picture is meaningless if you don't know what's hot and what's not. And then you need to know the units that it's in. If this was 28.5 degrees Fahrenheit as the max temp, that would be very different than if it's Celsius, right? 28 degrees Celsius is a nice warm day, but 28 degrees Fahrenheit, you need to bundle up. That's too cold. So I've been talking about temperature, and there's lots of applications for temperature. Obviously, you want to check the weather before you go outside. You want to know how to dress if you're going to be outside for a long time and not just running from your house to the store. You might need to put on more hats or gloves if it's cold out. You might need to wear a nice summer dress if it's warm out. So you want to make sure you're dressed appropriately. So that's one of the reasons we need to know temperature. When you cook or bake, you want to make sure that your cookies or your chicken or your vegetables are all being cooked at the right temperature and that they're cooked to the right internal temperature too. So you might use thermometers, but you might also have an IR thermometer to take these temperatures. And then whenever you're storing your food, if you want to store it for a long time in the refrigerator or the freezer, you might want to keep it around for a couple weeks so you can have a good meal waiting for you when you come back. You'll need to make sure that your food is kept frozen or at least kept cold and safe. They also do this in science a lot. They'll store things at very cold temperatures to stop viruses from growing or to stop a reaction from continuing. And then, of course, whenever you go to the doctors, you always want to make sure that you're healthy. The normal temperature, your normal body temperature is 98.6 Fahrenheit or 37 degrees Celsius. And that's become even more important now because people are very worried about people developing fevers as a symptom of a virus or some sort of infection. So why do we use infrared as opposed to just a thermometer like you might use? Because an infrared is real time. So I can just take a picture of this kangaroo. I don't have a lot of kangaroos around me in DC, but if I did, I would take pictures of kangaroos. And they don't like to sit still for a thermometer, right? So if I can just take a picture of one, then I can measure its temperature a lot easier. It's non-contact, so I don't have to invade the kangaroo's personal space. I don't have to get up close and personal with it. I can see it from a distance. If I have, something hot, something really hot and dangerous that I don't want to touch or I want to see if it's hot first, I don't have to get close or burn myself in order to interact with it. And then the other thing that it's really good at is fast. So you might have seen like high-speed camera images where you can look at a water droplet or butter or hummingbird wings flapping. So all of the infrared cameras are very fast and can watch these things happen in real time. So those are some of the benefits of using an infrared camera. So what are infrared cameras used for in the real world? Where might you encounter them? One of the first applications they were used for was for search and rescue and for firefighting. So, if you're walking into a burning building, it's hot. You know that there's this chance for danger. So identifying exactly where the hot spots are before you start busting down doors or going in to rescue people is really important for our firefighters. You can see on the pictures on the left, we have the left-hand side is what like your camera or what your own eyes would see. So the guy's looking through this cloudy, smoke-filled room, he can't see anything. But then on the right, with an infrared camera, he can clearly see that there's a person, laying on the floor that needs to be rescued. Same thing on the bottom image. They're looking for someone that's out in this lake or ocean, and they can't see them with just general night vision or even visual because it's too dark. But if you look at the lake with infrared, then you can easily see the warm body in the lake. So these are a couple good examples of when it can really be helpful to save people's lives. We also use them in telescopes. So a lot of the space instrumentation has infrared detectors on them. You can see the picture of the planet Jupiter there. It's obviously gorgeous in visible images, but if you look at it in infrared, then you can see where the hotspots are and really tell the temperature differences on the planet and see some other things that might be going on. There's infrared detectors on the Mars rover, so they can identify patterns in the soils of Mars, and many other applications for space. It's used a lot in transportation. People look at, the tires on your car after you've been driving for a while. Do they get really hot or not? I love looking at planes and helicopters flying with it because they're really pretty. And then one of the best ones is looking at an airbag. So hopefully none of you have ever been in an accident, but when you are, hopefully your airbags will deploy very quickly, like under a half a second. So you don't even get the whole 1/1000 out and the airbag's already in your face protecting you. So watching that with an infrared camera to make sure, it's not too explosive and it happens at the right speed and it's not going to burn anybody or hurt anybody has been really helpful for car manufacturers and safety certifiers. One of the other things it's used for is art. I actually worked on a project with the Library of Congress here in DC. They're looking at restoring a bunch of old books and manuscripts. And the paper that a lot of the old books were written on is really different from the paper that we use now. And so they were using infrared cameras to understand the properties of that paper. When they do restorations of art, so that's the picture on the left here, they use an infrared camera to understand more about what's underneath the different layers of the paint so they can figure out how to do a proper restoration of the material without hurting it. And then just some fun things, it's really gorgeous, right? There's the band 30 Seconds to Mars. They've done a couple videos now with our thermal imaging. This was from a live performance they did that was recorded in infrared, and it just looks so cool and interesting. And then if you start thinking about the science behind it, about why, his chest is warm and why he has that vest on and it's having different hot spots on it, it's all very interesting. And then the girl on the top left, she's an artist friend of mine. And if, she has the visual contrast with the thermal imaging overlay, it just creates some really neat patterns. So it's just fun to play with sometimes too. The house you live in is hopefully cool right now, good temperature, but a lot of that is because of insulation that's in your house. So sometimes home inspectors that come and check out your house and make sure it's good for you to live in, will use an infrared camera to make sure the doors are sealed, to make sure the windows are sealed. They can use these cameras to look for leaks too, to make sure there's no water damage that's been done to the foundation or in the attic or anywhere else. And then they also use it to look at your electrical panels. You don't want one of your outlets to, start sparking if you plug something into it, or your hairdryer to blow up when you plug something into it. So that's one of the biggest applications for these infrared cameras. I love animals. I love animals of all types and shapes and sizes. And so this is what I tend to gravitate towards. One of the coolest things that people have been using our cameras for is honeybees. So you might know that bees are in a lot of danger right now. And so they've been trying to understand how temperature and environment affects them, and the temperature of the hives, and if they're getting too hot, or if they're getting too cold, or what's going on with them. So you can see the picture on the top right. Those are actually all little honeybees in the honeycomb that they've made. FLIR works with the World Wildlife Fund to help prevent poaching. So like rhinos and elephants are sometimes in danger from people that want to take parts of their body or just kill them and hurt them. So we donate our cameras so that they can use them to track where the rhinos are and where the elephants are and keep them safe and make sure nobody's hurting them. And then these two little penguins are just hanging out. So the infrared cameras can be used, like I said, to just monitor these populations of animals from a distance. And you can see what they're doing late at night. So when you go to the zoo or something, or you see animals, it's in the daytime, but their behaviors and actions are really different at night, especially in these warm areas where, it's too hot in the daytime to do stuff. So they usually come out at night and then they start drinking water and playing around. And it's neat to see that from an infrared camera. And then one thing you might see it used for now, and you're probably going to run into a lot more infrared cameras, is for medical applications. So, it can be used to see if like your knee is swollen, if it's inflamed. There's a cool picture I took of just the veins in my arm. You can see the blood is much warmer than on my arm around it. But it's also being used for screening. So whenever you walk into a building or a large public gathering now, they want to make sure you don't have a fever or a high temperature, which can be a sign of an infection. So you may have to stop for a second and they'll take your temperature using one of these infrared cameras just to make sure you're safe and healthy before you go interact with other people. So that's all I wanted to cover today. If you're interested in a STEM career, or even if you're not, you may end up encountering one that interests you along the way. I just encourage you, no matter what, to be curious and ask questions. You may not get the answers to your questions. One of my favorites is always, why is the sky blue? And my response is always, but is it blue? Is the sky always blue? What about in the mornings or in the evenings? What about when there's clouds? So keep asking questions, and when you can, find out the answers on your own. And when you can't, then you can start asking people around you for suggestions of how to get the answers. And keep a lot of diverse interests. I thought I wanted to be a vet. That was my goal whenever I was a little kid. But then that sort of morphed along the way into I wanted to help animals in other ways, and it's just branched into a really diverse and happy life for me. Infrared is part of the electromagnetic spectrum. I know that's a big word, but it just means light. It just means waves, just like the ocean, except they're light instead. And it's all around you everywhere. And it's really interesting stuff. So if you encounter it in your classes, make sure you pay attention and find out how it interacts with you. And there's many applications for all of this stuff in your life. Like I said, I think you'll be seeing it more, just whenever you go into stores and interacting with people in the world. So that's all I have. Thank you guys for your attention and your time today and making time for Hannah and me. If you want to ask me some questions, I'm happy to now, or Hannah will be posting this online, so you can always send me some comments or questions later on too.
Okay. Does anybody have any questions for Mikala? No? Okay, thank you so much. That was amazing. And I really appreciate you coming on here to talk to all of us.
Thank you, Hannah. It was great.
Thank you. Okay. Thanks. I'm going to pause the recording.